We will choose model wizard. We can model 3D, 2D, 1D, anything can model. We will choose 3D model for our reactor. Then we have to choose the physics. For the physics, there are many physics. Fluid flow. In that fluid flow, porous media, subsurface flow, free and porous media. Study. Then we will choose stationary or time dependent. Then first we will model the geometry. We can choose the unit centimeters in the length. Then we can go to geometry here, and we can first build a cylinder. Cylinder will open. We can choose the radius of the cylinder as 15 centimeters, height 80 centimeters. Build all objects. A cylinder will appear. Now the annular channel cylinder is created. The next step is to create the packed bed cylinder. For that we have to create another cylinder. Then we will put the radius as 13 centimeters and the height as 80 centimeters. Build all objects. Inside cylinder will be created. Then we will go to booleans and partitions. In there we will choose difference, because we have to create a hollow cylinder to put the packed bed cylinder. Then we will choose the objects to add as the outer cylinder, and object to subtract as inner cylinder. Build all objects. Then we will get a hollow cylinder. Then again we will create a packed bed cylinder with a radius of 13 centimeters and height of 80 centimeters. Build all objects. Then the packed bed is created with the porous membrane. Now we have to create the annular channel membrane here. For that we have to create another cylinder with 12.8 centimeters radius and 80 centimeters as 80 centimeters as height. Build all objects. Then we can see that we have created a thin film membrane that acts as a perforated sheet. Then we will remove the inner part to create a hollow cylinder so that it won't overlap. Again boolean difference. For the objects to add, we can choose this outer cylinder, and objects to subtract as inner cylinder. Build all objects. Now we have created a thin membrane here. We can choose we have created a perforated sheet. Then now we will add the packed bed. Packed bed radius 12.8 and height 80 centimeters. Build all objects. Now we have added the packed bed. Then we have to add the center pipe. To add the center pipe, first we have to remove the area in the center so that it won't overlap with the center pipe we will create. So we will add a center pipe of 2.5 centimeters, 2.7 centimeters radius and height 80 centimeters. Build all objects. Now we have created center pipe, but it overlaps with the existing geometry. So we have to make it hollow. So we will go to difference, and we will choose the objects to add as outer cylinder, subjects to subtract as inner cylinder. Build all objects. Now we have created a hollow cylinder. Then we will create here also we have to create a perforated membrane. So we will choose build another cylinder with the radius 2.7 height 80 centimeters. Build all objects. Now we have created a center pipe. We have to remove the center pipe so we can create a membrane. Then for that we have to create a cylinder again with radius 2.5, height 80 centimeters. Build all objects. Now we can see that we have created a perforated sheet as at the center pipe. Then we have to make the difference. Choose the outer cylinder as objects to add and inner cylinder as objects to subtract. Then build all objects. Now we have created a perforated sheet. Then time to create the center pipe. For that, we can create another cylinder of 2.5 centimeters radius and height 80 centimeters. Build all objects. Now we have created a center pipe. The geometry is mostly completed except for the outer portion. We can do the dome in the outer to make it look like a reactor later. We can do that at the last. Now we have to add the physics. This is the free and porous media. We have to choose the materials. We go to materials. Then we have to add material to choose the which material is the fluid. We can choose air, type in air and search. There will be various number of air like liquid and air gaseous state. We have to choose the gaseous air. Here it is. We can choose the materials added as air. Then we have to define the porosity. To define porosity, we have to choose the close the add material section. To add a porous media, we have to right click on the free and porous media flow and choose the porous medium here. Then we have to choose which and all to make us the porous media. We will choose these three sections. So first is the outer perforated sheet, annular perforated sheet, then packed bed, then the inner perforated sheet. These three are the porous region, and two free area is the annular area and center pipe area. After choosing the porous medium, we have to define porosity there. To define porosity, we have to go to porous matrix, and we can choose the porous matrix as porosity as user defined, and we can define the porosity here as anything we want, like 0.3 we can choose as 0.3 for example. If we want to define three different porosities, we have to add the porous media 3 times. So we will add 3 times. For the first porous medium, we can choose delete. We can choose the outer perforated sheet, annular perforated sheet, and define its porosity as 0.15 void fraction. Then we can choose the second porous media, that is a packed bed, and we can define its porous porosity as 0.35. Then we can choose the inner perforated sheet, center wave perforated sheet. Then we can define that porosity as 0.05. We have added the porous mediums. Now we have to choose the where is the inlet and where is the outlet. Before that, we have to add the dome to create the outer dome. We will to create the outer dome. We have to open COMSOL new window. We will go to model wizard 3D. Then we can choose anything we want. We can choose laminar flow or anything we want. Study, stationary, done. For creating the dome, first we have to create two spheres at the top and the bottom of the reactor, so that we can create a dome. For that, we have to go to geometry, spheres, and add the radius of the sphere as 15 centimeters, and build all objects. We have created a sphere. Then we have to create another sphere of 15 centimeters for the bottom, and we have to define the position as we can create the upper sphere at 80 centimeters. And the bottom sphere at bottom. Now we have created two spheres. We only require a semi-sphere at the top and the bottom. To remove the remaining stuff, we have to create a cylinder. Cylinder of radius 15 centimeters, height 80 centimeters. If we build all objects, something like this will come. Then we have to go to Boolean and difference. And the things, objects we have to add are top sphere, cylinder, and the things we have to add are top sphere and bottom sphere, and the things we have to subtract are the cylinder. Now if we build all objects, we have got a dome at the top and the bottom. Now we have to make, we can also make the hole here itself for the center pipe. We can add the center pipe. For that we have to create a cylinder again of radius 2.5 centimeters, height is 80 centimeters, not 80, 80, 120 centimeters height. You can create a 1 centimeter height. From the z-axis is minus 20. If you create build all objects, something like this will pop out. Then we have to subtract the we have to remove the center this pipe, so that we can add a new one. You have completed creating the dome. For that you have to go to difference again. The things you have to objects you have to add are this upper and bottom dome. The things you have to subtract are center pipe. Build all objects. Now we have created a dome with a hole for the center pipe. We can now we can export. We have to export the geometry. To export the geometry, click on the geometry, right click and click on export. After clicking on export, we have to choose a file name. File name as we can name it as dome, and export entire finalized geometry compatible with anything. Okay, we have to browse first. We can save it in the desktop as dome, save, and we can export. Let's check whether it's got exported. Yes, here it is, dome. We have created the final. We have created the dome. Then we can go ahead and close this. Now we have to import that we have created dome here. For that we have to go to geometry, and click on import. Import will be here. We have to browse the location, desktop. Import. Now we have imported the dome. As you can see, it has been created. Then we first we have to increase the center pipe height, which is a center pipe. This one, center pipe height as 120 radius and position is -20 degree. The axis we have created. Now we have completed our geometry. We can close the geometry here. Now we have to define the where is inlet and where is the outlet. For that we have to right click on the free and porous media. There will be an inlet option. We can choose the inlet and we have to select the top here. We have selected, and for we have to next we have to create the outlet. We have to choose the outlet as bottom here. Now we have chosen the inlet and outlet. Now we have to choose the boundary conditions. We can choose inlet boundary, anything, velocity, mass flow, pressure, anything. We can choose the velocity as the inlet boundary condition, 0.1 meters per second. Outlet boundary condition is pressure 0 at the bottom. That's the outlet boundary condition. Now everything is completed. We can now go ahead and complete the mesh. Now we have to mesh. We have to choose the element type, element size. For now we can choose the coarser mesh and build all. The mesh has been completed. Now we have to start the simulation. For that we have to go to study and click here in the compute option. Then it will start computing. There's error coming. The following features encounter problem. Find material property kappa required by porous matrix 1. Yes, we have to define the permeability. We can define the permeability as 10 power minus 7. Here also permeability as 10 power minus 7. Here also permeability as 10 power minus 7. Now we can compute. Now the simulation has completed. We can see some of the results. For analyzing the results, we can go to velocity and add a streamline plot. And we can disable the others. Disable. We can choose a streamline from the study. We have to choose a data set from study one plot. There seems to be a mistake somewhere. Select all boundaries. You have to select all boundaries and plot. Now we can see that yeah, now that's the problem here, because the fluid goes directly at the center. For that we have to define a wall. We have to design the we have to define interior walls. To define interior wall, right click on the free and porous media flow, click interior wall. Now we have to choose which is the walls here. For that we can cut the symmetry in half. Now we have to choose the which is the interior walls. At the top, the interior walls is this enters into space and entering annular channel entering through here. So we have to choose it very properly. First membrane. This is also an interior wall. This is also a wall. This is also a wall, and the center pipe is also a wall. We have to choose the center pipe. Yes, that seems to be a problem. We cannot choose the wall at the center pipe because we have the center pipe is a one full length. To choose this place as a wall, we have to separate the center pipe into two cylinders. For that, we have to go to geometry again. We have to create another center pipe at the top alone. For that, we can create the center pipe at height 100. Now, as we can see, the center pipe only comes to till the catalyst bed. From there, we have to create another center pipe. For that, we have to go to geometry, cylinder, height 20 centimeters, radius is 2.5 centimeters, and the position is 80 centimeters. That coordinate. Now the center pipe has been completed. Now we have to go to interior wall. Now we will be able to choose the center pipe to define it as a wall. Yes, everything has been chosen at the top of the cylinder as interior walls. Now we have to choose the bottom interior walls. For that, we have to make it transparent and zoom on the bottom part of the reactor. For now, we have to the outlet is only at the center pipe, so we have to choose the remaining as walls. Yes. Now we have completed choosing which are the walls, interior walls. The interior walls has been chosen, and the boundary condition for wall is no slip. Then we can study again. Before studying, we have to make the mesh again, as we have made some changes. The mesh has been now created. Then we can go to study and start the simulation. seems to be a problem with the inlet. It seems that I have chosen the inlet as wrong, so we have corrected it and we are making the mesh again. We can start the solution again by going to study and compute. especially